So what questions do you have from the session? Maybe just type it in chat. Okay, so John McCarthy asks, to program a quantum computer, is there an abstraction as the language? Yes, as a matter of fact, there are actually several abstractions. One that I'd like to show you then is called KiSKIT. And so I'll go ahead and share my screen here. And this is one of the resources that's in the presentation. So there's resources called KizKit. It's an open source library. Let me verify that everybody can hear me. Everybody can hear me, correct? Just if somebody will say, yep, okay, good. Thanks, John. Okay. So this is just KizKit.org. And so if I click here, I get to KizKit.org. And there's different links here where I can learn about quantum computing. There's some really great learning resources. And you can choose, well, do I want to learn in a minute, in a day, in a week, whatever. So there's things like the KizKit textbook and some Medium blogs and tutorials, lots of nice videos. Every once in a while, we'll have a summer school. And but KizKit itself is a framework, and it's an abstraction, right? So it abstracts things, quantum computing concepts. And so if I go to the documentation, I can see that there's some tutorials, but there's also some API references. And it talks about those abstractions, like Terra has different fundamental kind of abstractions, like abstracting quantum circuits, the ability to visualize quantum states and circuits, and lots of things like that. So yes. Now, by default, the language that KizKit is written in is Python. So that's where we've done the most investment in time. So to program an IBM quantum computer, you would typically use Python and this KizKit API. Okay, so the Riemann hypothesis. I'm sorry, I don't know off the top of my head what the Riemann hypothesis is, but we're going to find out. I've heard of it, I just don't know what it is. Let's see. So we're going to Wikipedia that. Oops, it's org. And interesting. Yeah, so I don't know, but quantum computing there are classes of NP problems and other kinds of complexity class problems that it is good at, but just reading it really quickly, I don't know whether it would be suitable for that or not. Let's see. Okay, let's go back to screen here. Do these abstractions break down to translating your domain into matrices? Yes, right. So so all of this, everything in quantum computing is pretty much linear algebra. You know, the underlying mathematics for quantum computing is linear algebra, as well as some trigonometry on the unit circle, and and if you want to get deeper into some of the theoretical stuff, then you're talking about some calculus and differential equations and things like that. But you don't really have to go there for just normal quantum computing, especially if you're using some of the higher level libraries that we have. For example, if I go to KizKit and I say that I want to learn about, or I want the documentation on, instead of Terra, which is your lower level libraries, let's say I want to be able to use a higher level library to solve problems. And I want the library itself then to do all the quantum stuff. I want to work at this higher level of abstraction, like in finance or optimization or machine learning. So these are APIs that allow you to work at a higher level, but then underneath it uses the foundational things, which always includes all of your linear algebra, your matrices and vectors and things like that. Okay. So what are the questions you have, or what other things would you like to see? What would you like to poke into? Does it cost much to use this technology? Well, we are making it available because we're all kind of trying to figure these things out together, and so we found it best for the whole community to do that. And so we've offered, we're building quantum computers, but then we offer those to the community to use for free. So you can go in right now for free and play with quantum computing circuits, play with notebooks in Python, and when you use those notebooks in Python, then and you can run your programs on real quantum computers, and you can do that for free. We do have industry and laboratory and university partners that we have more powerful machines that we do. There is a cost for those, but these machines that we make available to the public are, here's one of, it's a 15 qubit machine. Here's some 5 qubit machines, and we'll be making more powerful machines and allowing the public to use those. So there's no cost to you other than your time for learning. So does NASA use it? So NASA is, I just spoke at NASA just a few months ago, talking about our quantum, just basically teaching some quantum computing concepts. And they have also been partnering with us even before that in um, trying to see how quantum computing can help their mission. And so, yes, NASA is very interested in this. Eddie says, can we use quantum computing in database searching? Yes, this Grover's algorithm is good for unstructured searches. Even anybody can search a structured database, right? Like a sorted database, but this quantum computing has a way of even doing an unstructured database faster. So I'll go to that slide again on Grover's algorithm. So this one here, on Grover's algorithm, we can, let's say that you had 1 million records in a database and it was unsorted. To guarantee that you actually find the record you're looking for, at the worst case, you would have to go through 1 million records. And the average case, you're going to have to go through 500,000 records before you find it. But with quantum computing, and this with Grover's algorithm, you can, instead of querying the database 1 million times, you could query the database 1,000 times. And the reason for that is Grover's algorithm is it has a quadratic speed up. And so with that algorithm, you only have to query the underlying database or search space, the square root of the number of records that are in there. So yes, you can do that. Now, there is an issue with how do you get those, those records into your quantum database, so that's, there's always that issue. How do you load the database? But from a theoretical standpoint, as far as like searching it, like we did with the party, inviting people to the party, yes, definitely can search a space quadratically faster. Okay. Is there a platform for simulation for student benefits? Yes. So that platform is right here, right? So this is the quantum experience, and you can run algorithms, including some optimization algorithms, in the quantum experience. So you would, like if we go to the documentation, the KiSKIT documentation, we can see that there are some tutorials here. And one of the tutorials is an optimization tutorial. And so we can go through here and see about optimization, the concept, for example, of quadratic programs, and how to load, how to make a model of one and load it. And then here in the next tutorial, it talks about how to make what's called a QUBO, a quantum, a quadratic unconstrained binary optimization problem that those run very well on quantum computers. So it's basically expressing the problem in such a way that it can be represented and solved on a quantum computer. And so in this particular tutorial is some code in the form of a Jupyter notebook. And so you could run this code in a Jupyter notebook, and it's basically all optimization code. And so yes, you can absolutely do that. Okay, a free or cheaper one. Is there a free or cheaper one? Constantine, yeah, I mean, you can go in for free and do that. So you don't have to pay anything to use our IBM Quantum experience. How long before John will have one at home? I don't know. How cold is your freezer? Is it 15 millikelvin? Is it almost absolute zero? Because right now the technologies we're using for quantum computers, it kind of requires that. So I'm not sure. I think it'll be a while because the technologies are kind of difficult to build. They're large. They're cold. They're expensive, so not sure. Okay, is there already any enterprise business case running in quantum computers? So there are example kind of programs where we're partnering with people. Like if I go to IBM Q Network, so this is our network where different partners, and some of them industry partners, connect with us, and we do research projects together. For example, one of our partners is JP Morgan. So we have different university partners, we have lab partners, we have network partners, we have industry partners. And so let's see if I can find some of the partners. Yeah, here's some of our partners. Daimler Chrysler, Accenture, Goldman Sachs, JP Morgan. So JP Morgan, for example, we are kind of researching together with them on things like option pricing and portfolio management. Here with ExxonMobil is modeling optimization problems for the energy industry. And so here with Boeing, modeling problems for, for reducing fuel consumption in airplane designs and things like that. And just, building an airplane is one of the ultimate optimization problems, building a jet. And so we are moving forward with all of these partners and lots more in creating smaller problems that kind of are trying to prove out, prove the concepts to see if those will be effective for larger problems as the technology matures. So those are some of the enterprise business cases. They're pointing to some enterprise business cases. So some of the enterprise business cases would be chemical, things like protein folding or drug discovery or things like that, and then optimizations and other things. Let's see. Would space be a good place to house a quantum computer? I don't know. Probably would. Is it a good fit for finite state models, like finite state machines and things like that? I think so. Structural design. Yeah, structural design would be good. Lots of optimization there. Okay, other questions? I really appreciated your participation. This has been a lot of fun, and it's really and it's also been really nice. No, John, no, that's what I'm here for, and I love to talk about this stuff. So does anybody have any other questions before we close off here? Okay, well, thank you very much for coming to the session, and I've appreciated talking with all of you. Have a great rest of your day. Thank you.